We're going to look at the 6 inverse trig functions, but before we do that, let me just go ahead and look at the original 6 trig functions, and then we're going to talk about what an inverse is and how we're going to have to define it specially for these particular functions. So we're used to the regular 6 trig functions: sine, okay, cosine, tangent, and then their reciprocals, right? So cosecant, secant, and cotangent. So we've got our 6 trig functions here. Let me just number them. Okay. Now what we're going to do is I'm just going to take a look at the sine function, and we're going to extend this to the remaining trig functions. So remember, the sine function starts at, let's grab blue here, starts at a height of 0, comes up to 1, down to 0. Okay, it looks like this. So this is sine, right? And of course this guy here is at pi over 2, this guy's at pi, this guy over here is at 3 pi over 2, this guy's at 2 pi, this is 0 radians. Now, what I want you to notice is that this function, well, first it is a function, so it passes the vertical line test. So because this passes the vertical line test, it implies that this is a function. Okay. Now, the question is, does this guy have an inverse, right? Does this guy have a function that undoes this function? So for example, is there a new function out there, okay, for which, let's say, if I asked what's the sine at pi over 4, you would tell me that's square root of 2 over 2. Is there a new function, we'll call it the inverse, such when I enter square root of 2 over 2 into it, I get pi over 4 out. So what this says is, what angle, when I read this right here, it says what angle has a sine value of square root of 2 over 2. That's the question that this is asking right here. And so we got an answer out of pi over 4, because clearly the sine of pi over 4 is square root of 2 over 2. Now, you might say, well, wait a minute. There's a whole bunch of these answers. There's a whole bunch of angles that have a sine value of square root of 2 over 2. For example, if I just take a look at the unit circle, and I grab a height value, close enough, of square root of 2 over 2, well, here's one angle at pi over 4, but look, here's another angle over here. And so this angle, this is pi over 4, 2 pi over 4, this guy, 3 pi over 4. This sine value at 3 pi over 4, that's also square root of 2 over 2. So this, to answer this question, we have an infinite amount of solutions, meaning that this is not unique. So what we need to do is we need to restrict the range, or the values that can come out for our inverse trig functions. Okay, so what does that mean? Well, it means that on this curve, this curve does not pass the horizontal line test, right? Because now watch, if I do more, I go like this, I didn't even have to do that much. I'll already fail right here. But watch, if I draw a horizontal line, it fails a whole bunch of times, which means that the original sine curve has no inverse. So here's what we're going to do. We're going to cut the sine curve so that it does pass the vertical line test. So here's how we're going to do that. What we're going to do is we're going to take the sine curve. Let me go ahead and graph it out here again for you. So this is the sine curve. And I'm going to extend it back this way because, of course, it heads down, back up. Okay. I'm going to do is I'm going to chop the sine curve from here to here. So from negative pi over 2 to pi over 2. Now what you'll notice is in that area, okay, I'm going to grab a different color here. On this area right here, okay, on that area, the sine curve is 1 to 1. It does pass the horizontal line test. So if I restrict the outputs, the angles that we can get out from negative pi over 2 to pi over 2, then sine has an inverse. So here's what I mean. Okay, so we're going to restrict we're going to have a new function. We're going to call this Arcsine. This is the function. Of course, it has an argument. Now what goes in the argument here is going to be a number between negative 1 and 1. Okay, so there's going to be a number between negative 1 and positive 1 that goes in here. Now what this function is going to do is it's going to spit out an answer where this number is an angle between negative 90 degrees and 90 degrees, or between negative pi over 2 and pi over 2. So that's how this function is going to work. So it now is a function. The inverse is now a function because it'll have a unique output. It won't have multiple outputs for the same input value. Okay, so let's go ahead and take a look at that. Let's say we said, what is the arcsine, or the inverse sine? Okay, so sometimes this is called arcsine. Okay, it means the same thing, so we can say arcsine. In fact, let me write it down like that for you. If we said, what's the arcsine, or the inverse sine, at pi over 6, both these two things say they mean the same exact thing. They say what angle, excuse me, I just goofed that up. I said that wrong. Let's do square root of 3 over 2, just so it's a little bit different. Okay, so what these guys say is what angle has a sine value of square root of 3 over 2. Now, where do we have to look for that angle? Well, we have to look specifically. Here's my unit circle. We have to restrict ourselves to these angles right here that fall between negative pi over 2 and pi over 2. So what we do is we go to a height value, because that's sine. A height value is square root of 3 over 2, which is right about here. So that height value is root 3 over 2. The angle, theta, that it makes is the answer. And so the angle that makes, we all know, is pi over 3. Just like that. Okay, that's it. So, of course, there's a whole lot of other angles that have this height value out. Okay, there's one over here. Then again, if I just keep rotating 360 degrees, or one revolution around, I'll keep ending up at this spot. So there's an infinite amount of values. However, we restrict our answers so that they fall between negative pi over 2 and pi over 2. And guys, pi over 3, here's 0. Here's pi over 3, somewhere in here, right? Okay, not to scale. So what you should do is you should try a couple problems. You should play around with some problems out of your book, okay, or off of the online stuff that'll help you play around with these. Now, we have some more restrictions for the other trig functions. So for example, we've covered this guy now. So the arc cosine, or the inverse cosine, the numbers that you get to plug in are just the same as the sine. Okay. However, we have a different interval on which we restrict the outputs. The reason for that is because if you graph the cosine curve, it would not be 1 to 1. Okay, it would not have an inverse function if we didn't restrict its outputs to this interval. So you can follow down and read through these, but I would encourage you in class to ask if you have any questions on those intervals and how that works.